Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by Rollbar. Rollbar is real-time error monitoring, alerting, and analytics that helps you resolve production errors in minutes. And I talked with Paul Bigger, the founder of Circle CI, a trusted customer of Rollbar, and Paul says they don't deploy a service without installing Rollbar first. It's that crucial to them.
We operate at serious scale, and literally the first thing we do when we create a new service is we install Rollbar in it. Like we need to have that visibility, and without that visibility, it would be impossible to run at the scale we do, and certainly with the number of people that we have. Like we're a relatively small team operating a major service, and without the visibility that Rollbar gives us into our exceptions, it just wouldn't be possible.
All right, if you want to follow in Paul's footsteps and start deploying with confidence today, head to rollbar.com/changelog. Once again, rollbar.com/changelog. Welcome to JS Party, a weekly celebration of JavaScript and the web. Tune in live on Thursdays at 1 p.m. Eastern, 10 a.m. Pacific at changelog.com/live. Join the community and Slack with us in real time during the show at changelog.com/community. Follow us on Twitter. We're at JSPartyFM. And now on to the show.
All right, hello, this is KBall here reporting live from React Amsterdam. In Amsterdam, I am here with Florian Rival, who is a software engineer at Facebook and has developed an open source gaming engine using React and WebAssembly. Florian.
Hi everyone, very nice to be there.
Yeah, thank you for joining me. So I'm really excited to hear more about the game engine. But first, so you're speaking a little later today.
Yes.
Can you give us a little bit about what your talk is going to be?
Yeah, sure. So the idea is that my talk is about using React and WebAssembly to create applications that are going a bit beyond what we used to do. So the idea is that I had this game engine that you just mentioned called gdevelop, and it was a whole C++ game engine. Desktop application that you can use on Windows, macOS, Linux. And I was like, okay, maybe I could port it to the browsers and have a kind of refreshed version because I've been using React for quite a bit of time, and I was like, React is really a good way of making interface. So is there a way I can remake the software in a better way using React? And that's how I happen to use WebAssembly to, in fact, port most of the software from C++ to WebAssembly. So my talk is basically about this and what were the challenge using WebAssembly and what are the things that we can use in the React ecosystem to make ambitious applications like a game editor.
So is the core engine still written in C++, but you're now compiling it to WebAssembly?
So yes, so there are the core classes of the software that describe what a game is, so the objects that are in a game and the rules that define the game. So the interesting thing about the software is that people can create their own game without programming because they are able to create the rules of their game using visual events. It's a bit visual programming in a way. And all of this is still in C++ because there are kind of lots of business logic that I didn't want to rewrite. All the tooling to convert your game from this structure in memory to a real game. At the end, games are running in JavaScript actually, HTML5, WebGL, and JavaScript. And then, so the idea was, can I take all this logic in C++ and convert it to WebAssembly? And that's what I did using a project called Mscripton, which is a Mozilla-backed project. Well, at the beginning, it was powered by guys at Mozilla. I think it's still the case, or maybe that has changed. Anyway, that's a really nice project that is basically a compiler, a C++ to JavaScript compiler, and now a compiler that is a C++ to WebAssembly.
That's neat. So can you give me the spoiler? What did you have to change to get that to work?
So, the interface that was the user interface of the software at the beginning was all done in C++ using a cross-platform toolkit called WX widgets. So there are other cross-platform toolkits like this in C++, for example, Qt. My idea was, can I remove this interface, this user interface from the code base? So I had to dig a bit in the C++ code to basically remove all the classes that were defining the interface, just to keep the core classes, the business logic, describing what a game is and all the tooling around it. And once you have it, you are then able to run mscripton, the compiler, but instead of at the end having an executable that you can run on your machine, you can run it as a WebAssembly module.
Mm-hmm. That makes a lot of sense. So essentially you are taking that UI that you want to replace with a React application and saying, okay, let's get rid of that and let's bundle this thing up so now I just plug it into my JavaScript and go?
Yes, that's the theory. In practice, there are a few things that you have to know, of course. So once you have your whole code base that is converted to WebAssembly, well, that's a very good start. You can actually see in the browser a few, for example, when you log things in the console, it's actually redirected to the console in Chrome. So you can see that things are running. So it's a very good first step. You can use mscripton like I did, but if you want to write WebAssembly from scratch, you can use things like language like Rust, or this interesting project called AssemblyScript, which is basically a kind of TypeScript that compiled to WebAssembly. So it's very interesting, and I mean, there are multiple ways of writing WebAssembly. In my case, I had an already existing code base, so I wanted to reuse it. So yeah, that's the first part. And then the other part is how to use it in JavaScript without creating too much memory leaks or this kind of things that we used to bother in the whole native language and that we kind of forget in JavaScript.
That's cool. Yeah, I think this is actually a really interesting area for WebAssembly of taking these existing engines that are out there that have targeted other platforms and saying, guess what? Now we can target them to the web and just plug into it the same way we would any sort of JavaScript module. Were there any major gotchas along the way?
So I would say that the first thing that you will see is that the bundle that is created, the WebAssembly module, is quite large. Depends on your code base, of course. But even for something that is quite small, if your code is, for example, coming from C++, you have the standard library that is coming along. So it's weighs a lot. Well, for example, for gdevelop, it's 3 megabytes. If the bundle containing all the WebAssembly code. Honestly, I don't care because I'm making an application, so I'm willing to have people wait a bit while they're downloading it. It would be better if it was linear, but it's okay. It's maybe something that will be improved, and it's already better because the first version of my port to browser of my app was using asm.js, which is a kind of subset of JavaScript that mscripton used to compile to, and it was 7 megabytes maybe. So things are progressing.
Yeah. Well, and WebAssembly megabytes are cheaper in some ways. They're the same amount over the wire, but parsing cost goes way down. And
yeah, and I think it depends on what you're making. If you're making a complex game or app, it might be okay to ask the user to download this bundle. And also, as I'm packaging the application as an Electron application, 3 megabytes, more or less, that's okay. So yeah, that's the first gotcha. The other will be more in using the classes, the bindings to your original classes in JavaScript, where there are a few things like memory leaks or passing the proper type of parameters that are really important.
You raise a really interesting point. A lot of times we think about WebAssembly, I'm going to run it on the browser and it's going to be there. But part of this for you, it sounds like, was just you wanted to use React for your UI, even if you're shipping it in Electron.
Yes.
Being able to have that seamless integration.
Yes. So actually, my starting point wasn't really about, I want to use WebAssembly. It was about, I have this existing application, and I know that I can make a better new interface using React. But how can I interface React with my existing code base? I don't want to rewrite the whole application in JavaScript. It will be too long, and I will lose the backward compatibility. So existing users will be like, your new software has less feature and is not working with our existing games. So no, it would have been a foolish idea. But still, I was really interested in React because I've been using React Native for making application and React for making websites or kind of application on the web. And I was like, we can do things that are really, really impressive with React. So let's try to port the whole interface to React and see how it goes.
It's interesting to think about this because React Native, as you kind of bring up, is sort of trying to do a similar thing. Let's use the React abstractions and ideas for native programming. Here we're taking something that wasn't originally planned for mobile or anything like that at all, and saying, you know what, it doesn't matter. We don't have to build it from scratch with this. We can just take out the UI component.
Yeah. I think that's I React the approach of React Native with the approach of React, but binding to native components. Here I'm doing a bit the reverse. I'm staying with React.js because I'm primarily targeting desktop users, so it's fine to run React.js and the performance is correct. But I'm still binding to existing native code that I don't want to rewrite and I want to reuse. So in my case, I'm reusing an existing code base that I did, but you could do the same with, for example, existing libraries that are doing computation like, I don't know, physics engine. I know that some have been compiled to WebAssembly, code base of game engine, of course, but also things like maybe physics simulation. I think that we'll see more and more people reusing or using WebAssembly module inside application without even us seeing it.
Yeah, well, and the cool thing about your approach is it's not limited to React, right? If you're a Vue user, if you're an Angular user, if you're an Ember user, if you're using any of these JavaScript frameworks, but you still want to package up a bunch of native stuff, now you don't need to wait for Vue native or what have you. You just package as WebAssembly and go.
Yeah. The actually, so in my talk, I'm speaking about WebAssembly for the first part, and then moving to more React-related stuff. But actually, it could be another framework. The cool thing with React is that it has a really huge ecosystem. And the second part of my talk, I more or less explain all the packages and open source modules that I've been using in React to make an interface that looks like a native interface with, for example, list of 100 or 1,000 of elements that you can virtualize, and things like if there are performance issues, how to deal with them, and other things like displaying trees of nodes. For example, in my software, the events that are describing the rules of the game, it's basically a tree that is displayed on screen. So how to do it properly with the DOM elements and React. But all these things could be applied to another framework.
Yeah, no, that makes a ton of sense. Were there any things that you found were missing coming into WebAssembly? Like I know, for example, the WebAssembly team is making a big push, or the WebAssembly coalition, I guess, is making a big push towards being able to do multi-threading and scripting across that. Was that something that proved to be a problem, not having those features?
So for me, it was okay because actually I don't have any performance requirement on WebAssembly because all the WebAssembly code that is running is, as I said, some business logic that can, it's not running the games. Games are actually in JavaScript at the end. But yeah, I think that the thing that I had the most problem with was debugging, especially when imagine that you're calling a function in WebAssembly. So you have some bindings, meaning that you have a JavaScript object, and when you call a function, then it's calling into the WebAssembly module. But if you pass the wrong type of parameter, let's say you pass a number instead of an object, then it won't be caught at the runtime. Then WebAssembly will think of the number as being a pointer to an object, and then it will mess up the whole memory. So you end up, if you're not careful, it's easy to break things, and it's not as forgiving as JavaScript. You don't have an error telling you, oh, this line, there is an error. You have a strange error telling you that the module has to abort because of some memory issue.
So how do you track those things down? What were the tooling that you had to apply in addition to just mscripting to compile?
So first thing is that I already had a set of tests in C++, but not enough, if you ask me. Yeah, that happened.
The universal developer situation, right?
Yeah.
Oh yeah, we have testing. Not enough.
Well, maybe not. So yeah, what I still did was that when when you have your WebAssembly module, you also have to create bindings that describe the classes existing in C++ or in your language that you want to expose to the JavaScript world. And when writing this, I've also been writing tests to check that I can create a new object, like I call a method on it, and that it's returning the proper thing. Just because I wanted to be confident about the fact that it was really working. The first time you're like, there should be a gotcha that it's gonna crash at some point. So I started to write this, and basically what I've been doing without knowing is I created a set of tests on the interface of my library, because at the end what I have, it's a library.
Right.
And this thing is giving you great confidence into the fact that it's working. And also, if later something is crashing, you already have a test telling you that, okay, the base case is working, so maybe I've been misusing something, but it's working. So it's on me to fix it. It's not on WebAssembly.
That makes sense. Yeah, you have to be... Well, and now you're bridging from a compiled language where perhaps you have stronger types and things like that into a dynamic language like JavaScript. You have to do a lot more validation of your inputs and things like that.
Yeah, exactly. And I've been looking at things to automate the creation of flow types or TypeScript types for the library that is generated. It's still not a thing. I've seen a project called Endbind that allows to compile your C++ code base to asm.js, so it's still not WebAssembly, but they are making automatic generation of typing. So I'm really missing this. I hope that we'll see more and more tooling creating these types. On the JavaScript side, I've been using Flow to type all my stuff. So at least I have not the safety as strong as a really strongly typed language, but still at first I started without. And now I cannot write any code without types because I'm getting more confident, and this kind of things that are easy to debug in JavaScript, that they are there in WebAssembly. So I want to be sure to pass the proper things.
Yeah, it is an interesting example of how these things that are convenient but maybe not necessary in JavaScript, suddenly they become a requirement when you start bridging into other languages.
Yes, and speaking of types, I'm a big fan of the typing system like TypeScript or Flow. Turns out that it's not really necessary when you're starting, but as the app is growing, it's really convenient to have typing that help you to refactor. Well, help you or someone else, like a contributor or another teammate. And in fact, when you're back to your code base after a few months without dealing with it, you're a stranger to your own code, and types will save your life at least, or it's telling you, okay, you have removed the prop in this component, but you've not done it in the rest of the code base. So it's a really powerful tooling that I guess is really shining a few weeks or months after you're writing the code.
Yeah, it's the type of thing that doesn't feel like you need it when you're getting started, and then as complexity grows, as contributors grow, you really wish you'd started it from the beginning.
Yeah, sometimes I'm back on some components of the user interface that are not typed, and like, wow, what I was thinking? No. I mean, it's okay, it's working well, but it's a good thing to add typing and to have the peace of mind that things will be all right.
This episode is brought to you by DigitalOcean. DigitalOcean is the simplest cloud platform for developers and teams with products like Droplets, Spaces, Kubernetes, load balancers, block storage, and pre-built one-click apps. You can deploy, manage, and scale cloud applications faster and more efficiently on DigitalOcean. Whether you're running one virtual machine or 10,000, DigitalOcean makes managing your infrastructure way too easy. Head to do.co/changelog. Again, do.co/changelog.
So it sounds like you have kind of a mixed background. You're coming from like a C++ and more traditional programming, and now you do a lot of web and React and things like that. I think our audience, we have also mixed background. I don't know, the listener here might have just JavaScript, or they might be coming from all of those. But for someone who is just used to coding for the web and JavaScript, can you talk a little bit more about the things to wrap your head around if, for example, you wanted to come and start using your game engine, or you wanted to start working with some other native libraries? Like, what feels different?
Yeah, I mean, The thing that is really nice with JavaScript is that there is a simple mental model for how objects are living. Basically, you're creating a new object, and as long as it's not garbage collected, as long as you have a reference to it somewhere, then it's still there. I think the important thing to think about where you're using WebAssembly with at least C++ might be better if WebAssembly is getting garbage collected at some point. For now, it's not the case. So I think the most important thing is to make sure that you understand the lifetime of your objects. I'm creating a new WebAssembly object, for example, when my component is mounted. Then I have to destroy this object when the component is unmounted. Otherwise, the JavaScript object that is the shell around the WebAssembly object will be garbage collected, but the inner WebAssembly object in memory will stay there. So I think that's also something that I had issue with. At some point, for example, I created a new WebAssembly object, then I deleted it at some point, and without seeing it, I was reusing it at some other point. So it was a crash again.
Yeah.
That's the thing that you want to look at when you're starting, especially if you're coming from a more web background.
Yeah, that makes a lot of sense. And I do know that is another big area the WebAssembly consortium is working on is garbage collection, because that will smooth a lot of how do we interact with this via JavaScript and make sure that we're able to actually communicate objects back and forth rather than having a wrapper around it and serialization and all of that mess.
Yeah, it's true that, sometimes what I do in my components is that I get the WebAssembly object as a prop or I create it, depends on what I do. But then sometimes I more or less convert it to a JavaScript object so that I can then pass it down to other components. And I don't care about the lifetime and all these things. So I think that if WebAssembly is getting a garbage collection, it might ease the whole usage of it and bring additional safety. I'm pretty sure that I have some memory leaks in my application. I hope not too much, should be okay. But still, it's manual memory management. Yeah, that's the downside for now.
Is there any tooling available for debugging those memory leaks? So no, on the native side, there are lots of different tools that folks use. Have any of those things been ported to WebAssembly?
I'm not sure. I've not seen any tooling like this. Hopefully that will appear. I've seen people, when you compile your WebAssembly module with some debugging flags, you're getting source maps. So for example, you can see in your Chrome debugger the source in C++, and that's you can go from one line to the other. And that's really awesome. In my case, as I said, I have quite a lot of tests, so I'm actually confident in the fact that it's working. But if you're writing from scratch, it's a good idea to see if it's working, at least to see your Rust or assembly script or your C++ code base in Chrome. That's really fun.
Yeah, no, that's really cool. But I feel like for the memory management stuff, that's tricky because it seems like a lot of the natural bugs are actually going to be in the interface. You can test one side, you can test the other side, but are you letting these things go? Well, that's an interesting question. So how would you write tests that bridge between your C++ code base and the JavaScript?
Ideally, you won't, and you would have an automatic generation of these bindings. At least the thing that in my case, as I'm using Mscripton, I'm using some language called WebIDL. It's a Java-like way of describing classes. So this thing is used by Mscripton to generate glue code. So that means that it's exposed on the JavaScript side the classes, and on the C++ side, it's calling the method. So at least if I'm making a mistake here, the C++ won't compile. But still, if I pass too much or too less arguments on JavaScript side, nothing will happen. So that's why I think that automatic generation of typings will help.
Yeah, absolutely. I'm just thinking about, if JavaScript is calling in to something that's going to allocate memory, and then JavaScript owns that object and is required to then call in to deallocate, to write a test, we're going to kind of have to bridge across.
Yeah, right. I think that there is no good solution for now, except maybe automatic garbage collection. Basically, you can't really test for manual memory management. You just have to be careful.
Yeah, absolutely. So you talked a little bit for the game engine, your target is kind of laptop, desktop, things like that. Is this also a methodology that will work for targeting mobile applications?
I think that could be so. If you're running an application, a native application, and you want to reuse your native code base, well, if it's C++ or even Rust, maybe I've not tried, you might as well compile to a native library and reuse it in your iOS or Android application. I would say a bit the same in React Native. If you want to reuse a native library, you can keep it as a native module. But I think this is getting interesting for mobiles, for progressive web apps, for example. There is an example made by some Google developers. It's called the Squoosh.app. It's a PWA, but running WebAssembly code to reduce the size of an image and to do transformation on an image. And it's open source, so it's a good example for people that want to start. And I think that we'll see more and more application, web apps, and even web apps for mobile that are running some kind of WebAssembly, and that using this we might get something that is not as fast as a native app on mobile, because native is still has a lot of compiling advantage when it's come to making user interface. It's super smooth and so on, but you never know, with WebAssembly running your business logic or maybe some part of your interface that might get really smooth and good enough to say that it's an app and it's not a progressive web app or a web app, it's just an app.
Yeah, no, this is really interesting. And I think one of the very nice things that WebAssembly gets you is it's got all these great sandboxing utilities, and then you now, if you're using WebAssembly and JavaScript, you have access to NPM and all of this incredible ecosystem that is much more expansive than might exist in.
That's what I liked really with JavaScript, is that sometimes people are complaining about, oh yeah, I'm doing NPM install and getting tons of modules that I don't know what they're doing. Actually, that's the weakness and the force of the whole ecosystem. When I'm back to working with C++, I want an easy function to do something. I can't find it. I have to write it from scratch. Or I can find it maybe in a library, but then it's a pain to install. So I think that's really the huge strength of the JavaScript ecosystem, is that you can npm install basically anything.
Anything. Yep. The strength is you can npm install anything. The weakness is you can npm install anything.
Yeah, exactly. But I want to say that when people are sometimes like, oh yeah, there are tons of modules that are being imported, I'm like, yeah, but the C++ standard library, it's huge too. And we cannot iterate as fast because it has to go through a standardization process. It has advantage and disadvantage, but the reason I've written the whole interface in React is because I think that React and the JavaScript ecosystem is better now and faster at developing good and advanced interface.
Yeah, JavaScript just moves faster and the web moves faster, and there's pros and cons to that. It's a constant effort, and I think one of the things that the fact that every project then ends up having 1,000 dependencies and sub-dependencies means is we need to improve the tooling around that.
Yeah. Give more visibility on what you're importing, maybe some more checking around what's really inside your bundles, code splitting, and conversely, things that are in native are not yet in JavaScript, but things are improving. I like to look at even the language JavaScript. It used to be a scripting language, and now with all the ES6 and all the typing that we can add, we are moving toward a really robust language. And on the contrary, things like language like C++ are now introducing things like lambdas and automatic typing. So things are going in the same direction actually.
Yeah, absolutely. When you were talking about the size of the WebAssembly bundle pulling in the standard library, so is there any concept of tree shaking when you talk about compiling, we've got this standard library, but maybe I'm only using 5 functions. And sure, they use 20 more underneath the covers, but 25 out of however many thousand.
Yeah. So there is no code splitting or tree shaking. In a way, there is. For example, when what language like C++ and compilers have been doing since a bit of time is that when you're compiling your whole software and using a library, only the functions that are actually used will be included in the binary at the end. So it's basically tree shaking.
They're already doing dead code elimination or whatever it's called.
I think that dead code elimination might still not be 100% exact, so you're still having more libraries that you want to have. I think that I've seen things like how to have some kind of dynamic libraries in WebAssembly. That means that you could have your native code that is required only when it's really needed. So I don't know, for example, if you have a physics engine that you want to reuse, if it's a 2D or 3D, there might be a way to exclude the 2D library or the 3D library according to what you're doing.
Yeah, that's starts to get really interesting. And there's some progress towards saying, okay, do we want to have a standard library for JavaScript or something like that, so that the browser just already has all these functionality? When we talk about WebAssembly and pulling in the C++ standard library, that is a standard. Yes. Why not?
Yeah,
why not just have it bundled with the browser?
You have to get the good balance between enough innovation in your ecosystem and still something that is robust enough. People like to say also that, for example, when the package was leftpad was removed from NPM, that was the end of the world. In a way, it was. But I think that still it's not a problem about the ecosystem. It's a problem about the thing that package should be immutable and shouldn't be able to be removed, maybe. But that's things that we can improve. And that's great to see that in the JavaScript ecosystem, we are able to build on things that are as small as some really simple function of a few lines, and then get more and more complex stuff. So in a way, that's maybe the dream of open source.
Yeah.
Or using stuff as much as possible.
Yeah, the 1,000 module situation comes from the fact that module bundling used to be tricky. It used to be expensive, so you'd only do it for very big things. Yeah. But now it's so easy and simple, at least in the JavaScript world, that why not?
Yeah, you can npm publish something in a few minutes. And it's also something that I like with, for example, React, is that when you have your tree of components, you have a large component, it's easy to take a bit of JSX somewhere, extract it to a new component, and reuse it really quickly. And I think this feedback loop that is really quick is important in whole stage of the development, including in libraries. If you want to make a new C++ library, that takes a bit of time to get the whole tooling set up. That will be a nightmare if you compare it to NPM. I hope that things that are compiling to WebAssembly like Rust are improving the ability to create libraries really quickly, because that's how you create an ecosystem that is exploding instead of growing linearly.
Yeah, well, and we seem to be figuring out some of the factors that make that possible. I think an emphasis on refactorability and composability is huge. That was one of the driving, at least stated motivations for hooks, is it makes it easier to cut and paste code and refactor it into new locations and sort of move things around.
I was speaking about typing. I think it's a bit the same, is that when you're investing a bit in some tooling like this for making things easier to refactor, then it's a huge win, because some people told me, but if you make small modules, you will have things that have a simple interface, so you don't need typing, for example. That might be true, but on the other way, you can't say that you will never refactor something. Even a small module you want to at some point add or remove something. I mean, even components, it's a strength of React is to be able to move components easily. And I think that's something that you want to keep, is your ability to refactor things without breaking things. So that's why I think typing and having a library that allows you to create a component using only a function, that's a really great thing.
Yeah, well, and anytime you are exploring somebody else's module, having those types is really useful, because I don't know, am I using this right? Oh, it didn't compile, the types are wrong. Okay, now I know what I need to do.
Yeah, that's basically documentation, and it's a safety net. So it's particularly useful for a library. This being said, it depends on your use case. I have the website of gdevelop, the game engine, which is done in React using Gatsby, but I have no typing, because there I don't really care. The model of components that I have with React is enough to get something that is working well. Well, this being said, I'm the only one, more or less the only one to be working on it, so I might change my opinion if I get more contributors.
Yeah, okay, so I want to explore that a little bit, because we just talked with Jason from Gatsby, and so we were hearing a lot about what they have working and sort of the inside view, but you're coming in, you're using it as a user. What's your impression of Gatsby?
I've been very happy with it. I'm a big fan of the React approach, because when I was redesigning the website, I was like, I can identify components in the design that I want for my website. So I wanted to have an easy way to start a website. So I started to look at Gatsby and all the performance that come with it. I've been very happy with it. The website is running really fast, and the development experience is also really nice because there is auto reloading, which is something that's a bit hard to set up, but well, it comes for free with Gatsby. So yeah, I only have actually good things to say about Gatsby and the ecosystem around it.
Yeah, it's funny thinking about, these days with Webpack and various things, we almost take for granted, okay, auto reloading, I make a change, it's just going to be there. But that's a phenomenal upgrade in productivity because of that iteration speed.
Yeah. That's the feedback loop in the development that is really important, that is being improved by this. That's the reason why I reported my software interface to React, because I can use Storybook, auto reloading. Well, I'm not using auto reloading, but at least things like Storybook to develop your components in isolation. That's a huge speed improvement. And yeah, to come back to Gatsby, I think that it's making out of the box most of what I wanted for my website. So I went with it. And the thing that I like is that if at some point I want to scale the website more, I'm not afraid because it's based on React. I know that there is an ecosystem around it. I know that if I want to add some, I don't know, for example, a part of the website where you have to be sign up, you can do it because at the end it's all React. And still, it's server-side rendered, so I get something that is blazing fast.
Yeah, it is amazing how fast Gatsby sites are, and they're doing a lot more than just the server-side rendering. They're doing a lot, a lot of the pre-rendering. Like they're really emphasizing how do we optimize this to make it super fast.
This episode is brought to you by Keen. Keen makes customer-facing metrics simple. It's a platform that gives you powerful in-product analytics fast with minimal development time. For example, a DIY solution to build out customer-facing metrics in your product could take 6 months or more, and with Keen, you can be up and running in the same day. The Keen platform lets you stream events to easily collect and enrich your data, compute with embeddable answers, insights, and metrics, access control so you can design role-based access to your data, and of course, a visualization layer to create stunning charts. And we have a special offer just for our JS Party listeners. Go to keen.io/JSParty and get your first 30 days of Keen for free. And as a bonus for checking out a 15-minute demo of Keen's customer-facing metrics, they'll send you a free Keen t-shirt. Go to keen.io/JSParty. Again, keen.io/JSParty.
Want to swing back now. So we're talking about the importance of auto reload and that kind of fast iteration. When you're working in your C++ code base, is there a way to hook it up so that you get automatic recompile and changing, or like how does that end up working?
At some point, I'd like to have the compiler running after every change. That would be possible. Basically, the compilation is there is a package.json that is running mscripton and compiling the C++ to the WebAssembly module. So I could more or less do my own watcher for files and rerun it every time I'm modifying something. So right now, my feedback loop is changing something in the C++ code base. I'm using VS Code that has a good integration actually with C++, so I can even get errors directly in VS Code. So that's the first thing that is important, get the errors displayed in your editor. So you're not getting, C++, you can get errors at compilation that takes your whole terminal. So having a good idea to start is, I guess, the main thing. And then I have a terminal. I run the npm run build, then the test just after, and then I can, when the tests are passing, it's copied to the node modules of my React application. And at this moment, as there was a change, the app is reloading. So it's still longer than I would like to, but it's not that bad because I remember doing a change in C++, then recompiling the whole thing for a few seconds when you're lucky, then running the native application, going to the page, well, not the page, the screen where you want to test and see that, oh no, that I made a silly mistake. Let's start again. Now, I have less this because as my C++ code is more or less my business logic, I can test it faster using test, unit test. And the interface is done in React. I can use something like Storybook and I have my component displayed directly. So I'm much faster at writing components and interface, and I'm equally as fast as writing C++ for business logic.
Yeah, you kind of get the best of both worlds there.
Yeah, I guess that once you are okay with the gotcha that I told, you get the best of both worlds. That's what I want to show in my talk. Not saying that you will have a great experience all the time, but that's something that is working. That's working.
Yeah. When I've seen, talking about the build steps, so it sounds like you have a manual build still, but I've seen people do like Webpack integration, just essentially pulling in C++ or Rust stuff as modules directly into Webpack.
I have to check that. That's surely possible, especially for a language like Rust or any new language that compile to WebAssembly. They have something to play on the side of integration with JavaScript. Yeah, I'm using Create React app for the React application. I highly recommend it. I don't want to mess too much with the initial setup. I want to be able to upgrade it easily. That's why I'm okay with having a manual build step that I launch. But even this I could improve. I could do a watcher by myself. Or maybe later there will be some kind of integration between Mscripten and Webpack. We'll see.
I haven't looked at the newer versions of Create React app because I've been more in the Vue ecosystem recently. Do they still require you to eject to customize the Webpack config, or do they use the Webpack Compose?
So I don't think they're using Webpack Compose. I will have to check to be sure. But now you can use Babel macros. So for example, I've been adding internationalization, to the app. And I've been using JS Lingui, which is using some Babel macros to have you, so that you are able to use a component inside your application to translate strings. And basically, they're changing the AST, they're parsing the JavaScript and changing the AST. That's all done using macros and without ejecting.
That's cool. Yeah, I love the way that essentially like metaprogramming in the JavaScript ecosystem is growing up, because we're now addressing things that, there's the application layer, but then there's even this compilation layer. We're using it to do things like JSX, Babel macros, all this other fun stuff that is, kind of compile time abstractions.
Yeah, there is. I'm not sure if it's some newer language, like maybe it's Reason ML, or other language that for sure they are allowing you to extend the syntax by manipulating the AST of the language. So basically, it's a meta language that you can create. You can create your own language in the language. I think that's very powerful, and something that we're starting to see in the JavaScript ecosystem. At least it was very convenient because I didn't have to eject for using the translation component, and so the result is very lightweight.
Yeah, no, I love this. I used to do a lot of creating these domain-specific languages using Ruby. But there it's all runtime, and it's Ruby, which is slower. Here we can do it at compile time using Babel, and it's lightning fast, and you get, Rust has this idea of cost-free abstractions. That's basically what this is. It has a cost, but only at compile time.
Yeah, that's great. And there have been, in a way, the template metaprogramming in C++ was the same idea, but it's super easy to use. So I'd like to, most of the time I'm avoiding to do it in my own code base. It's super convenient for libraries, but also a pain to use.
Yeah.
And a pain to debug.
Yeah. Well, it sounds like pain to debug is kind of a theme as we go along. When you start moving, if you're starting from the web and you're used to the tooling that's available in the web, it's funny because we used to say, console log debugging became a thing because the tools was so bad. Now the tools in the web are so good that anytime you kind of go away from it, you're like, wow, I miss my...
You mean I can add a breakpoint without recompiling? That's strange. But this being said, if you've never tried, for example, native development on mobile, the experience is also pretty good if you start Xcode or Android Studio. So good things have to be picked up from both worlds.
Yeah, absolutely. Awesome. Anything else coming to mind you want to chat about before we wrap up?
Nothing much. Just check out gdevelop. It's my game engine. It's for people. It's for anyone because of the visual programming system. Anyone can jump in the software and start making games. So make sure to check it out.
And it's all open source, right?
It's all open source.
If you want to see a practical example of compiling WebAssembly, using that, integrating it with JavaScript and an application, there you go, gdevelop.
Exactly.
Awesome. Thank you so much, Florian.
Thanks a lot.
All right, thank you for tuning in to JS Party this week. Tune in live on Thursdays at 1 p.m. US Eastern at changelog.com/live. Join the community and Slack with us in real time during the shows. Head to changelog.com/community. And do us a favor, share this show with a friend, rate us on Apple Podcast, go into Overcast and favorite it. And thank you to Fastly, our bandwidth partner. Head to fastly.com to learn more. And we move fast to fix things around here at Changelog because of Rollbar. Check them out at rollbar.com. We're hosted on Linode Cloud servers. Head to linode.com/changelog. Check them out and support this show. Our music is produced by Breakmaster Cylinder. And you can find more shows just like this at changelog.com. Thanks for tuning in. We'll see you next week.